Hello everybody. Once again I am here with you for the waves and oscillation paper number 6. Myself again Dr. S.D. Chauhan, Department of Physics, Adarsh College, Hingoli. In the previous session we have seen a little bit introductory part as good as the two important factors, that is to be what is wave velocity and the particle velocity, and differential equation of wave motion also we have seen. And basic things already we have seen in detail, that what means to be wave and how waves are to be there, how the waves are going to be generated, and what is mean by the basic fundamental things whenever we can discuss or whenever we can say a wave motion is to be there. Now related with this part again, as the wave is going to be generated, what happens as far as the propagation of the wave is going to be there? Either any amount of energy is going to be transferred in that case, that we will see in the today's topic. So let's start what is there for this today's session. Now as good as we have already seen what is mean by to be as an wave, and what exactly to be as an wave means to be there, as the steady medium is to be there. I am disturbing it, throwing any or disturbing, creating any disturbance in that steady medium, and whatever be the steady particles or the atoms or the molecules at the front surface, that will get disturbed and vibrations are going to be generated. And the vibrations of the particle is to be their steady medium, that is to be from their mean position to extreme position, and the repeated and periodic motion or the vibrations of the particles are nothing but to be giving you the wave motion is to be there, or the wave is going to be generated. Now as the wave is generated, we already seen what exactly the difference as far as the wave velocity and the particle velocity is to be there. As the wave is going to be traveling, that means to be propagation of the wave is going to be in one direction, that is to be again the particles vibration, it is from their mean position. That means velocity of the particle and velocity of the wave is to be having little bit difference, whatever differences that is we have already seen. Now as the wave is going to be propagating, in that case what amount of energy is going to be transferred, or what exactly meaning to be as a wave means propagation is to be there. Now wherever the wave is going to be generated, we are aware about that it is nothing but to be particles vibrations at their mean position. In that case the particle or the matter is not changing, only the wave is going to be traveling, and in this case matter is not going to be transferred from one place to another place, but the wave is going to be traveling in that case. So in this case what amount of the energy is going to be transferred? And as far as wherever we can say energy means to be, it is having the two parts, that is the kinetic energy as well as the potential energy is to be there. And when the total energy or energy word comes, it contains both the kinetic as well as the potential energy is to be there. Now how there is to be as an in wave motion, there is kinetic energy and the potential energy is to be there. To understand it again, we have to take into account that what is the velocity of the wave, or the wave is to be vibrating of the particles are to be there. As far as the velocity of the particles, vibrating particles are to be there, it is related with the whatever be the your kinetic energy is to be there. That means whatever the velocity is going to be generated as far as particles vibrations are there, that means the wave is going to be propagating. In that case the particles vibration or the velocity of that particles are nothing but to be giving you related with the kinetic energy. And as far as the we are aware about that the particle when at their mean position, that means at the steady medium, the whatever be the vibration disturbance created, the vibrations are nothing but to be the disturbance created. Now the particles will vibrate throughout their mean position, means that will the particle will vibrate not anywhere, that means to be as in from its mean position to extreme position, again back to the mean position, again extreme down, and again back to the mean position. Likewise the vibrations of the particles are to be there. It means that the particle may be at mean position or may be at extreme position. Now what about the kinetic energy? As far as we are considering as a velocity or the vibrations of the particle, that means to be velocity of the particle or the kinetic energy is going to be maximum at their mean position. When the particle is at mean position, then there is possibilities of maximum velocity of the particle is to be there. But as far as particle is at extreme position, there is less chance to be get vibrate again, and that's why it is having the very minimum kinetic energy at the extreme position, at the top or at the bottom is to be there. These are nothing but to be as far as what exactly meaning to be or the kinetic energy maximum or the minimum points are to be there. Now what happens as far as the displacement of the part or whatever be the potential energy part is going to be there. Wherever the potential energy in the wave, we can say that is to be related with the displacement of the particle is to be there. The particle is going to be displaced, that is to be the part related with the potential energy. There are number of particles at their mean position, and that is what displacement of the particles are to be there. Again, the potential energy as far as going to be concerned, it is it is maximum at the extreme position. The whatever be the potential energy is going to be, it is maximum reverse to the kinetic energy. It is maximum at extreme position and it is minimum at the mean position is to be there. This is vice versa as far as the your kinetic energy and the potential energy parts are going to be there. We are aware about that the longitudinal waves, wherever we are discussing about the energy in the longitudinal wave, it is nothing but to be, we are aware about that if the disturbance is created at the center of the pond and the waves will be of a different, that means to be whatever be the longitudinal waves are going to be there, the energy in that case is not to be as a uniform. It is going to be distributed, and that is not to be uniformly distributed, because wherever you are creating a disturbance at that time it may be max, and when you are coming to the end point or the corner, that is to be having the different waves velocities are to be there. And that's why in this particular longitudinal part is to be there, it is having somewhat change in this case. Now as far as the longitudinal waves are there, it is compression and rarefication is to be there. Now the previous one was example related with the your transfers, but spring is to be compression, whatever the compression and rarefication is to be there, rarefaction is to be there. In this case at the point of no velocity, that means the no compression is to be there, at that time no energy is going to be there. That means in the your as far as longitudinal waves are going to be there, we are aware about that whatever be the vibrations of the particles are there, it is to and fro along the direction of the propagation of the wave. ज्या दिशेने वेव्ह ट्रॅव्हल होत आहे किंवा जात आहे त्याच डायरेक्शनने जर पार्टिकलचं व्हायब्रेशन होत असेल तर दॅट इज नथिंग बट टू बी युअर लॉन्जिट्युडनल वेव्स आर टू बी देअर. As we are aware about that, the waves types of the waves are two, that is transverse and longitudinal. As far as transverse waves are going to be there, it is nothing but to be vibration of the particles are perpendicular to the direction of the propagation of the wave is to be there. And as far as longitudinal waves are to be there, the vibrations of the particles to and fro or along the direction of the propagation of the wave is to be there. So in that case we are aware about that there is a compression and rarefaction is to be there as far as longitudinal waves are to be there. And at no velocity, that means to be no compression is to be there, no energy at that case is to be there. At the point of where the maximum velocity is to be there, that means the compression is where, then it is called to be as a maximum energy is to be there. That means at the rarefaction there is no energy, there is no velocity, there is no energy is to be there. As far as the compression is to be there, there is maximum velocity, maximum energy is to be there. And this is what the where the compression is to be there, there is a velocity and there is a energy is to be there. As far as longitudinal waves are going to be there, in all cases either it is transverse waves or longitudinal wave, the important factor is that the only there is transfer of energy is to be there, not the matter or the medium is going to be transferred. Wave is traveling, that means the energy is going to be transferring, not the medium or the matter is going to be transferred. That is what we have already discussed, but right now also it is related with the energy part. That's what we have to be careful about this. Now moving forward, what exactly or how to calculate this propagation of wave as far as energy of a plane progressive wave is to be there. And in this case when we want to find out the propagation of the wave or the energy, in that case to find out exactly how much amount of energy is going to be transferred, that is to be there. Now again related with this case, it is very important factor. Just it is not like that the one wave is created and then again we have to stop for the another wave. The wave is continuous, that's why the energy transfer is continuous per unit area per unit time. That means to be as an, once the wave is going to be generated, continuously per second the waves are going to be coming out, so the energy is also going to be transferred per unit time, that is to be there. And that's what the important factor to rate of flow, that is also we have to taken into account for the calculation of energy as far as the propagation of the wave is going to be there. Now in this case again we will start with no doubt our very important equation, that is the displacement of the particle shows with the equation of simple harmonic wave motion is to be there, and that is nothing but to be given here with this your simple one, that is to be y is equal to a sine twice pi lambda vt minus of x. This is what the your first or the very important equation. We already discussed in detail how it is going to be generated, and that's why I told that time that this one is the very important equation for the two units, and that is what the y is nothing but to be displacement, a is nothing but to be amplitude of the particle, and lambda is nothing but to be wavelength, small v is nothing but to be your velocity of the wave, t is the time period part is to be there, x is the position of the particle, another particle is to be there. So in this case y is nothing but to be simple harmonic wave equation, and if I want to find out, as the y is the displacement, then if I want to find out the velocity, it is nothing but to be rate of change of velocity is nothing but to rate of change of displacement, that is displacement with respect to time, that is velocity is to be there. And in that case if I find out, that is to be u here written with this case, that is dy by dt, and that is I have to differentiate this equation number 1 with respect to the t, and if I am differentiating this equation number 1 with respect to t, then it will be become u is equal to dy by dt, that is what u is nothing but to be notification used for the velocity of the particle is to be there. Now here again the multipliers of the t, because we are differentiating with respect to t, that's why we have to focus only about the what part is in the multiplication with the your t, that is v is to be multiplication with twice pi by lambda is also in multiplication, so it will come forward, and that's why it is becoming to be twice pi a v by lambda is to be there, and this is what the twice pi a v by lambda. Sine so will cos, that's why this sign will become to be cos, and as it is twice pi by lambda vt minus of x, this is what the your velocity of the particle is to be there. If I want to find out the acceleration, in that case also, that is this part we already discussed in the last two sessions in detail. Now again if I want to find out acceleration, what is acceleration? It is nothing but to be rate of change of velocity is to be there. That means I have to differentiate again this equation number 2 with respect to t is to be there, that is d dt of dy by dt, that is d2y by dt square is to be there. So if I am differentiating again this part, no doubt the differential part or the differentiation is with respect to t, that's why the t is multipliers are going to be affecting, that is twice pi by lambda v is to be there. हे पुन्हा पुढे येईल, so it will become 4 pi square a v square by lambda square, so that's why 4 pi square a v square by lambda square. Cos होत असते minus sign, that's why this is here again the minus, if here it is written, but if you have not seen carefully, it is minus of this value, because why? Cos minus sign, so minus for this and sign for this conversion, so sign of again the same value is to be there. This is what the your acceleration, it is noted with the small f is to be there, and that is nothing but to be du by dt is nothing but to be d2y by dt square is to be there. So this is what the acceleration as far as the particles are going to be concerned. Now negative sign is not meaning to be as in something bigger thing is going to be happening, because just as we are aware about that the particle is either moving away from the mean position or coming back to the mean position, and the negative sign indicate that acceleration of the particle directed towards the mean position, that means the particle is coming towards the mean position, and that's why this negative sign is to be there. That is the only case where whether the particle is going away from the mean position or coming towards the mean position, and that is what the acceleration is given with this case d2y by dt square is to be there. Again, if I wants to find out the total energy as far as the propagation of the wave is to be there, already we discussed that whenever the energy word comes, I have to take into account the both the things, either it is potential energy as good as your kinetic energy is also to be there. So in this case, first we will see about what exactly the potential energy part, if I want to find out as far as the your propagation of the wave is going to be there. Now in this case, few parts are very much important. That is, wherever the displacement of the particle, we know that y is nothing but to be the very important factor which is to be showing you displacement of the particle is to be there. So here if you look at this case where it is to be as an y is nothing but to be the displacement of the particle is to be there, and that is from the mean position. That means particle is moving always from its mean position to extreme position. In that case, to move the particle from the mean position, it is not directly go. As the medium is at steady, either I am creating any disturbance, then and then only the particles are moving. Either I want to move this pencil, I have to use some external force, that is to be displacement is supposed to be. I have to do some work, and for this doing against the work for moving this particular pencil or any particle is to be there. In that case, I have to do some work against the acceleration is to be there. So already I calculated the acceleration of the particle, so I have to take into account what amount of work done I needed for that particular wave or for that particular particle's acceleration part is to be there. That means I have to do work against that acceleration is to be there. Then and then only I will get particularly as a amount of potential energy part is going to be there. So as far as work done part is to be there, and the displacement is nothing but to be y is our complete displacement. That means to be from this mean position, this is suppose the extreme y displacement, but at any instant it will, the particle will move for first here, then here, then here, then here, and on, and it will reach to extreme position. But the small interval is nothing but to be dy, and it is small change, that is nothing but to be d. Y is the displacement, that's why small amount of the displacement, that is nothing but to be given as a dy. So amount of work done, what amount of the displacement I am doing, I need amount of that force acceleration against that work done is to be there. So the whatever be the displacement dy is to be there, this particularly work done, if I want to find out, it is nothing but to be f into dy is to be there. So here if you look at the whatever be the f is nothing but to be the force into this displacement, that is to be as an your work done is to be there. Wherever the work done part is to be there, force and the displacement, हाऊ मच अमाऊंट मला ही पेन्सिल इथून किती दूर अंतरावर न्यायची, तेवढ्या अमाऊंट ऑफ वर्क मला जर करायचं असेल तर तेवढ्या अमाऊंट ऑफ फोर्स आणि तेवढ्या अमाऊंट ऑफ डिस्प्लेसमेंट मला अप्लाय केलं, तेव्हा ही पेन्सिल फ्रॉम वन प्लेस टू अनदर प्लेस जाणार. काय केलं, मला जेवढा वजनाची पेन्सिल उचलायलो तेवढं फोर्स लागेल, वजनदार आणखीन काही उचलत असेल तेवढं फोर्स मला लागेल, आणि तितकं अंतर किती डिस्प्लेसमेंट करायलो तेवढं अमाऊंट ऑफ द डिस्प्लेसमेंट. सो फोर्स into displacement is nothing but to be your work done is to be there. So in this case roughly we are discussing in that case, so it is to be there what amount of, as far as the your and this all the things work done against the acceleration is to be there as far as the particle parts particle of the your wave are going to medium are going to be concerned. Now in this case of suppose let density is the very important factor again. So what exactly the rho is supposed to be as an taken here to be as an density of the medium. Suppose whatever the medium water or whatever you have taken, rho is nothing but to be the density. In that case the important factor again to be displacement for the density, what amount of density is to be there, the according to that work done per unit volume for the displacement dy. Now the very important factor again to be as an volume part. So as work done we need force into displacement, but again force is related with the what part is to be there, again the force is nothing but to be mass into acceleration is to be there. Why these quantities are raising, work done is equal to whatever be the force into displacement, that is f into dy is nothing but to displacement, f is nothing but to be the force. Now force I am going to be calculating in that part as far as the your waves are medium particles are to be concerned. In that case, rho is the density of that medium. What amount of density is to be there, according to that the mass will be there. The density and the mass is having the relationship, and the volume is also to be there. So once if I want to find out the force, in that case if I want to find out this quantity to be as an F is to be there, F dy I know that displacement dy is to be there. But if I want to know force in that acceleration point of view, then I have to find out first of F is meaning to be what. F is nothing but to be force, is nothing but to be mass into acceleration is to be there. Now what is mass? Again the very basic quantity. Mass is means to be what? That is density and the volume is the very important factor. Wherever I can say the force is nothing but to be mass into acceleration. F is equal to ma, in roughly we can talk. Acceleration we have, but what is about the mass? Mass is again related with the density and your volume is to be there. So now suppose I have taken into account density as a rho here for an example, or for your consideration. Rho is suppose the density, and I want to know the per unit volume mass is supposed to be as an, here is nothing but to be per unit volume, that means 1. In that case, whatever be the force per unit volume, that is nothing but to be the F, that is nothing but to be force per unit volume, that is to be as an volume will become to be as a 1, density is rho, that is 1 into rho, and that's why the F will be rho. And here for replacing this quantity as far as work done, so work done is equal to rho into dy, that part will be there. So here in this case, the whatever be the your quantity, the become, that is work done is equal to F into dy. This F is going to be replaced with this rho into whatever be the your acceleration part, that is here F is equal to ma, that means to be mass is nothing but to be here rho is only. Why it is to be there? Per unit volume, that is calculated. The whatever be the work done per unit volume, if I want to find out per unit volume, means the volume is 1 in that case. So volume is 1, unity 1, and at that time when the volume is 1, we are aware about that volume into density is nothing but to be your part where the mass is to be there. As far as the mass is to be becoming to be rho, a is nothing but to be acceleration, then what work done will be there, that we are aware about that for the work done it is F into dy. Now here F is equal to ma we have, and that is what the F is equal to ma. The ma quantity is nothing but to be here that mass is becoming to be your rho, and acceleration already you have calculated, that is 4 pi av, this quantity is to be there 4 pi square av square by lambda square sine of twice pi by lambda vt minus of x is to be there. This is what the quantity showing here for the your force. How it comes, that is very important. And dy is nothing but to be displacement. Simply work done is equal to काय, force into displacement, that is F into dy. पण आता force म्हणजे काय, तर force म्हणजे mass into acceleration. Force म्हणजे mass into acceleration. पण आता force per unit volume, that is work done per unit volume, या केस मध्ये mass and mass is nothing but to be given with whatever be the volume into density. पर युनिट व्हॉल्यूम म्हणल्यामुळे व्हॉल्यूम होईल 1 युनिट म्हणजे 1 इंटू डेन्सिटी आपण कन्सिडर केलेली आहे रो, म्हणजे मास या ठिकाणी काय होईल 1 इंटू रो म्हणजे रो होईल मास. मग फोर्स जर मला क्वांटिटी काढायची असेल तर मासला तिथं काय घ्यावं लागेल, रो घ्यावं लागेल. का बरं रो? ॲक्च्युली पर युनिट व्हॉल्यूम, इथं व्हॉल्यूम जर वेगळं असतं तर व्हॉल्यूम इंटू डेन्सिटी आलं असतं, ते तुमचं मास झालं असतं. पण या ठिकाणी पर युनिट व्हॉल्यूम म्हणल्यामुळे व्हॉल्यूमची क्वांटिटी किती व्हायली 1 व्हायली, आणि 1 इंटू रो म्हणजे रोच, आणि म्हणून मास इथं काय झालं रो झालं. मग इथं फोर्स कॅल्क्युलेट करताना मासची व्हॅल्यू किती आली आहे रो आली. पण ॲक्सलरेशन आपण मागच्या इक्वेशनमध्ये काढलं, दॅट इज 4 पाय स्क्वेअर ए व्ही स्क्वेअर बाय लॅम्बडा स्क्वेअर साइन ऑफ ट्वाइस पाय बाय लॅम्बडा व्ही टी मायनस ऑफ एक्स. हे आपण काढलेलं मागच्या आत्ताच्या इक्वेशनमध्ये. इफ यू लुक ॲट दिस इज व्हॉट द पार्टिकल्स ॲक्सलरेशन, हिअर यू हॅव कॅल्क्युलेट दिस वन इज टू बी देअर. तेच मी लिहिलेलं आहे, हे 3rd नंबरचं इक्वेशन. सो या केसमध्ये माझजवळ आता मास म्हणजे रो आणि तुमचा ॲक्सलरेशन म्हणजे 4 पाय ही जी क्वांटिटी एवढी लिहिली मी. ही क्वांटिटी कशाबद्दल लिहिली? ही क्वांटिटी लिहिलेली आहे फक्त आणि फक्त तुमच्या या फोर्सबद्दल, दॅट इज टू बी एफ इज टू बी बद्दल. म्हणजे हे रो इंटू दिस 4 पाय दिस क्वांटिटी, ही एवढी क्वांटिटी कशाबद्दल लिहिली मी? ह्या फोर्स एफ बद्दल लिहिली. आणि dy काय आहे? dy इज नथिंग बट टू बी डिस्प्लेसमेंट. दॅट इज व्हॉट? फोर्स इंटू डिस्प्लेसमेंट, युअर वर्क डन इज टू बी देअर. आणि आता ह्या केसमध्ये मग जेव्हा मला हे वर्क डन dy म्हणजे काय? स्मॉल अमाऊंट ऑफ डिस्प्लेसमेंटसाठी आहे. जर समजा मला टोटल वर्क डन पाहिजे, म्हणजे स्मॉल अमाऊंट ऑफ डिस्प्लेसमेंट काय? dy. टोटल डिस्प्लेसमेंट मी काय म्हणतो? y. एक्स्ट्रीम पोझिशनपर्यंत जाणं म्हणजे y डिस्प्लेसमेंट. पार्टिकल एक्स्ट्रीम पोझिशन इथपर्यंत चालला म्हणजे काय? कुठपर्यंत? y. टोटल डिस्प्लेसमेंट इतकं आहे, पण त्याच्यातला मी स्मॉल अमाऊंट घेतला म्हणजे काय घेतला? dy. तो dy म्हणजे स्मॉल अमाऊंट ऑफ वर्क डन, दॅट इज वर्क डन पर युनिट व्हॉल्यूम मी कॅल्क्युलेट केलं आहे आत्ता फक्त. आता मला काय पाहिजे? टोटल वर्क डन पाहिजे फॉर द डिस्प्लेसमेंट y. कम्प्लीट डिस्प्लेसमेंट y साठी मला वर्क डन पाहिजे असेल तर मला इंटिग्रेट करावं लागेल हे इक्वेशन फ्रॉम काय? 0 to y. That's why I am integrating this equation, integrating 0 to y for the rho 4 pi square av square by lambda square sine of twice pi by lambda vt minus of x dy is to be there. So again, if you look at this case, ह्याच्यामध्ये काही विशेष असं नाही आहे. टोटल डिस्प्लेसमेंट y आहे. y सुरुवातीपासूनचं जे इक्वेशन आपण लिहितो सिंपल हार्मोनिक इक्वेशन y इज इक्वल टू a साइन ट्वाइस पाय लॅम्बडा vt मायनस ऑफ x, त्याच्यातला y हे डिस्प्लेसमेंट आहे आणि a ॲक्सिल ॲम्प्लिट्यूड राहते. आता हे y आहे टोटल डिस्प्लेसमेंट. मग ह्या टोटल डिस्प्लेसमेंटसाठी मला जे कॅल्क्युलेट करायचं आहे ते पर्टिक्युलरली तुमचं वर्क डन. आता टोटल वर्क डन फॉर द डिस्प्लेसमेंट y म्हणजे टोटल मला ही पेन्सिल इथून इथपर्यंत न्यायची, तर हे झालं टोटल डिस्प्लेसमेंट. पण इथून थोडंसं अंतर नेणं दॅट इज dy इज टू बी देअर. पण टोटल इथपर्यंत नेणं दॅट इज कम्प्लीट y डिस्प्लेसमेंट इज टू बी देअर. सो डेस्टिनेशन पार्ट. नाव आता ह्या केसमध्ये इंटिग्रेटिंग दिस इक्वेशन फ्रॉम 0 to y. 0 to y का? कारण टोटल डिस्प्लेसमेंट y म्हणून 0 to y इथपर्यंत नेलं मॅक्सिमम y पर्यंत. सो आता हे जर इंटिग्रेट केलं मी तर हे इक्वेशन जर समजा तुम्ही केअरफुली सिरियसली बघताल त्याच्यामधला हा पार्ट a इंटू साइन ऑफ ट्वाइस पाय बाय लॅम्बडा vt मायनस ऑफ x, हे इक्वेशन ॲज गुड ॲज तुमची व्हॅल्यू इंडिकेट करते. सिंपल हार्मोनिक वेव्ह इक्वेशन दॅट इज y इज इक्वल टू a साइन ट्वाइस पाय बाय लॅम्बडा vt मायनस ऑफ x. ह्या इक्वेशनचाच ह्याच्यातला पार्ट आहे, सिमिलर आहे. म्हणजे ह्या पार्टबद्दल मी y लिहू शकतो इथं कारण हा कॉमन पार्ट असल्यामुळे. मग मी जर समजा ह्या क्वांटिटीमध्ये ही क्वांटिटी रिप्लेस केली तर इथं काय उरणार आहे? रो 4 पाय स्क्वेअर ए गेलेलं आहे व्ही स्क्वेअर बाय लॅम्बडा स्क्वेअर, ए तिकडे जाणार आहे ए साइन ट्वाइस पाय बाय लॅम्बडा vt मायनस ऑफ x, त्याच्याबद्दल y लिहिणार dy. म्हणजे उरलं कोण आता? रो 4 पाय स्क्वेअर व्ही स्क्वेअर बाय लॅम्बडा स्क्वेअर ह्याच्याबद्दल y आणि dy. सो न्यू रिलेशन विल बिकम लाईकवाईज दिस. मग ह्याच्यामध्ये काय होईल? ह्याला जर रिप्लेस केलं ह्या पार्टला तर मला नवीन इक्वेशन जे मिळणार आहे पोटेन्शियल एनर्जी पर युनिट व्हॉल्यूमचं, तर बिकॉज पर युनिट व्हॉल्यूम वी आर गोइंग टू कॅल्क्युलेटिंग. सो ह्या केसमध्ये मला जे इक्वेशन मिळणार आहे ते काय मिळणार आहे? 4 पाय स्क्वेअर, रोला मी मधात लिहिलं व्ही स्क्वेअर बाय लॅम्बडा स्क्वेअर 0 to y इंटिग्रेशन इज टू बी देअर y dy इज टू बी देअर. आता 0 to y लाच इंटिग्रेट का करतोय आता मी? y dy लाच, कारण आता इंटिग्रेशन कोणाचं आहे? 0 to y. मग इफेक्ट कोणावर होणार आहे? y क्वांटिटीवरच इफेक्ट होणार आहे. 4 पाय स्क्वेअर रो v square by lambda square, these are going to be constant. They will not get affect with this y because y is related with the displacement part and that's why these quantities are going to be the constant, म्हणून ते बाहेर आले. मग y dy याला जर इंटिग्रेट केलं 0 to y इंटिग्रेशन 0 to y y dy. सो वी आर अवेअर अबाउट दॅट. ह्याच्यावरच आपली जी 12वी निघाली y dy एवढ्या इंटिग्रेशनवर, त्याच्यावर त्याचं सिम्पली जर समजा कॅल्क्युलेशन जर केलं तर मला आपल्याला माहिती आहे इट इज नथिंग बट टू बी ऑलवेज टू बी y स्क्वेअर बाय 2 इज टू बी द इंटिग्रेशन इट विल कम आउट. सो मग ह्याच्यामध्ये ही जर क्वांटिटी टाकली, आता इथं काय केलं, हा बाय 2 जो y²/2 हा मल्टिप्लिकेशनमध्ये आणि बाय 2 जो होता हा लॅम्बडाच्या ठिकाणी लिहिला, एवढंच केलं. म्हणजे 4π² रो v²/λ² इंटू y dy बद्दल काय होणार आहे, y²/2 होणार आहे. मग 2 फक्त इथं लिहिला मी, ह्या इथं हे डिवायडेड बाय असल्यामुळे 2λ² एवढंच लिहिलं आणि इंटू तो वरच आहे कोण y². मग आता इथं हे लिहिल्यानंतर मुद्दामून ही क्वांटिटी अशी ठेवली, बिकॉज पुन्हा काय होणार आहे, बे का बे, बे दोन्ही 4, दॅट विल ऑल्सो गोइंग टू बी चेंज. मग इथं उरणार कोण आहे, द रिमेनिंग व्हॅल्यू विल बी 2π² रो v², हा y² उरलेला तो बाहेरच आहे, डिवायडेड बाय λ² इज टू बी देअर. आता y² ला मुद्दामून बाहेरच ठेवलं, कारण पुन्हा आपल्याला त्याची क्वांटिटी yची जी व्हॅल्यू आहे ती पुटअप करता येते. मग इथं उरलं कोण, 2π² रो v²/λ². मग इथं सेम तेच केलं, 2π² रो v²/λ², हे y² ॲज इट इज बाहेर. वी आर कॅल्क्युलेटिंग दिस पोटेन्शियल एनर्जी पर युनिट व्हॉल्यूम. सो आता ह्याच्यामध्ये y² कोण आहे, दॅट इज y इज नथिंग बट टू बी a sin 2π/λ vt मायनस ऑफ x. ही क्वांटिटी जर इथं टाकली तर इट विल बिकम y². मग y² आहे तर a चं होईल a², साईनचं होईल sin² 2π/λ vt मायनस ऑफ x. So this is what the total potential energy per unit volume as far as the wave propagation of is to be there. आता ही 4 numbers equation that is giving you the potential energy part, but the job is not over. Still we have to calculate another part, that is the kinetic energy, because when I want to calculate the total energy for that propagation of the wave, I have to count first. I already calculated now the potential energy. Now we are going to calculate the kinetic energy. Now kinetic energy, we are aware about that, it is nothing but to be half mv². Again the part comes here to be as an the same thing, that wherever the mass is to be there, mass इथं या ठिकाणी kinetic energy per unit volume, पुन्हा per unit volume आहे. That means again to be mass is nothing but to be, again इथं simply पुन्हा तुम्हाला लक्षात राहावं, mass is nothing but to be volume into density. पण आता per unit volume म्हणलंय, kinetic energy per unit volume, म्हणजे इन जनरली kinetic energy इज इक्वल टू काय लिहितो आपण, हाफ mv². हाफ mv², m म्हणजे मास, v म्हणजे वेलोसिटी. आता ह्या ठिकाणी u जे आपण रिप्लेस करायलो, वेलोसिटी ऑफ द पार्टिकल u इज इक्वल टू आपण लिहिलंय, त्याच्याबद्दल आपण u² लिहिलं. आता इथंच फक्त प्रॉब्लेम आला, हा रो कुठून आला. आता हा रो कोण आहे, हा रो आहे बेसिकली तुमचा डेन्सिटी. इट इज रिप्रेझेंटेशन फॉर द डेन्सिटी इज टू बी देअर. पण आता इथं पर युनिट व्हॉल्यूम म्हणले, म्हणजे मासला रिप्लेस केलं इथं रोनी. आता पुन्हा इथं व्हॉल्यूम पर युनिट व्हॉल्यूम, म्हणजे व्हॉल्यूम किती आहे इथं, 1 क्वांटिटी 1 आहे, युनिटी 1 आहे. मग 1 हा व्हॉल्यूम आहे, रो ही डेन्सिटी आहे, आणि व्हॉल्यूम इंटू डेन्सिटी असते मास. म्हणून यमला इथं मासला रिप्रेझेंट कोण करायले, रो रिप्रेझेंट करायले. म्हणून हाफ रो u² म्हणजे वेलोसिटीचा स्क्वेअर आहे. आणि दॅट्स वाय दिस इक्वेशन विल बी देअर. कायनेटिक एनर्जी पर युनिट व्हॉल्यूम इज नथिंग बट टू बी हाफ रो u² इज टू बी देअर. अगेन वी आर अवेअर अबाउट दॅट. u म्हणजे काय आपल्याला माहिती आहे, आपण आत्ताच कॅल्क्युलेट केलेली व्हॅल्यू आहे, दॅट इज 2π/AV/λ cos of 2π/λ vt मायनस ऑफ x, त्याचा होल स्क्वेअर होईल u, म्हणजे हाफ रोला रो ॲज इट इज, हाफ रोला रो. ही क्वांटिटी जी आलेली आहे, ही क्वांटिटी ॲज इट इज आपण मागे जे u कॅल्क्युलेट केलेला आहे त्याचा स्क्वेअर आहे. जर समजा तुम्हाला थोडंसं हे वाटत असेल तर हे इथं बघून घ्या. u इज नथिंग बट टू बी हिअर, अगेन रिलेटेड विथ द पार्ट इज नथिंग बट टू बी हिअर, u इज टू बी हिअर. हे बघा, 2π/AV/λ cos of 2π/λ vt मायनस ऑफ x, दिस इज युअर पार्ट वेअर इट इज टू बी u इज टू बी देअर. मग ह्याच यूचं इथं काय, वेलोसिटी ऑफ द पार्टिकल आहे, त्याचा स्क्वेअर मी इथं घ्यायलो. मग स्क्वेअर घ्यायलो इन दॅट सेन्स इट इज टू बी ॲज अन 2π/AV/λ cos of 2π/λ vt मायनस ऑफ x होल स्क्वेअर, एवढ्याचा वर्ग. मग आता हाफ रो ॲज इट इज, हाफ रो ॲज इट इज. आता ह्याचा जर स्क्वेअर केला तर व्हॉट विल बी द न्यू व्हॅल्यू, 2चं होईल 4π² a² v² डिवायडेड बाय λ² cos square of 2π/λ vt मायनस ऑफ x, cos square of this value. आता दिस इज व्हॉट. आता याच्यामध्ये थोडंसं ट्रिग्नोमेट्रिक जर केलं, हे 4 आहे इथं 2 आहे, म्हणजे बे एक बे, बे दोन्ही 4, दॅट्स वाय इट इज टू बी रिमेनिंग 2. आणि म्हणून उरलेली क्वांटिटी काय, ट्वाईस पाय स्क्वेअर ए रो इथं ॲज इट इज लिहिला, ए स्क्वेअर व्ही स्क्वेअर बाय लॅम्बडा स्क्वेअर कॉस स्क्वेअर ऑफ ट्वाईस पाय बाय लॅम्बडा व्ही टी मायनस ऑफ एक्स. This is what the kinetic energy per unit volume. But still job is not over. This is your kinetic energy per unit volume. Already the previous equation calculated potential energy per unit volume. Now wherever the energy is to be there, it is kinetic energy plus potential energy is to be there. Whenever the total energy per unit volume, if I want to calculate, in that case I have to know, I know that it is energy is nothing but to be potential energy plus kinetic energy is to be there. Now potential energy, we are aware about that, the equation number 4, that is it is with the twice pi square rho v square by lambda square a square sin square twice pi by lambda vt minus of x. This is the quantity for the equation number 4 that you have calculated. And the another, this is potential energy per unit volume. And kinetic energy is already we calculated, twice pi square rho a square v square by lambda square cos square twice pi by lambda vt minus of x. ही जी पहिली क्वांटिटी आहे जी मी अंडरलाईन केली, ही काय, पोटेन्शियल एनर्जी. जर विश्वास नसेल तर पुन्हा एकदा बघा, पोटेन्शियल एनर्जी पर युनिट व्हॉल्यूम बघा, ट्वाईस पाय स्क्वेअर रो व्ही स्क्वेअर बाय लॅम्बडा स्क्वेअर ए स्क्वेअर साइन स्क्वेअर ऑफ ट्वाईस पाय बाय लॅम्बडा व्ही टी मायनस ऑफ एक्स. हे इक्वेशन नंबर 4 ॲज इट इज इथं आलेलं आहे, हे बघा, हे ॲज इट इज इथं. आणि कायनेटिक एनर्जी पर युनिट व्हॉल्यूम, दॅट इज ट्वाईस पाय स्क्वेअर रो ए स्क्वेअर व्ही स्क्वेअर बाय लॅम्बडा स्क्वेअर, हे इथं बघा, ट्वाईस पाय स्क्वेअर रो ए स्क्वेअर व्ही स्क्वेअर बाय लॅम्बडा स्क्वेअर कॉस स्क्वेअर, दॅट इज कॉस स्क्वेअर ऑफ ट्वाईस पाय बाय लॅम्बडा व्ही टी मायनस ऑफ एक्स. So this is what the total energy what you have written for the potential energy plus kinetic energy. Now look at this equation carefully. If you look at this equation carefully, here you will found some common factors in the both the quantities, that is twice pi square rho v square by lambda square into a square. इथं पण आहे twice pi square rho v square by lambda square into a square. ही क्वांटिटी इथं पण कॉमन आहे. जर मी ह्या इक्वेशनमधून कॉमन काढली, इथं पण आहे सॉरी, ह्या ठिकाणाहून जर कॉमन काढली तर उरलेलं कोण आहे, साइन स्क्वेअर ऑफ ट्वाईस पाय बाय लॅम्बडा व्ही टी मायनस ऑफ एक्स प्लस कोण उरलं दुसरं, कॉस स्क्वेअर ऑफ ट्वाईस पाय बाय लॅम्बडा व्ही टी मायनस ऑफ एक्स. सो हे मग इक्वेशन काय लिहिलं, हे कॉमन काढलं मी पार्ट कोणता, ट्वाईस पाय स्क्वेअर रो व्ही स्क्वेअर बाय लॅम्बडा स्क्वेअर इंटू ए स्क्वेअर, आणि उरलेली ही साइन स्क्वेअर दिस क्वांटिटी प्लस कॉस स्क्वेअर दिस क्वांटिटी ॲज इट इज लिहिली. पण आणखीन एक जे सिम्पल रिलेशनवर आपली मॅथमॅटिक्स 12वी निघालं ते म्हणजे साइन स्क्वेअर थिटा प्लस कॉस स्क्वेअर थिटा इज ऑलवेज गोइंग टू बी 1. म्हणून ही क्वांटिटी या ठिकाणी काय होईल, दिस विल बी कमिंग टू बी ॲज ए 1. सो इन दॅट केस जर समजा ही क्वांटिटी इथं 1 झाली, कोणती, साइन स्क्वेअर ऑफ दिस प्लस कॉस स्क्वेअर ऑफ दिस क्वांटिटी, हे बघा, हे sin square of this quantity plus cos square of this quantity is similar, in that case it will become to be as an 1. So remaining value is this much of amount. So this is what the remaining quantity, that is 2 pi square rho v square by lambda square into a square. मग त्याला जर आता मध्ये घेतला मी, हे into आहे, so that's why it is the having the value. So it is again, ह्याच्यामध्ये पुन्हा एक पार्ट आहे, E is equal to sorry this much of amount you will get again, but we have the relationship v is equal to n lambda, that is wave velocity is equal to frequency into wavelength of that case. So again n is equal to I can write v by lambda, पण इथं v by lambda कसं आहे, मग ह्याचा जर स्क्वेअर केला मी तर n स्क्वेअर इज इक्वल टू v स्क्वेअर बाय लॅम्बडा स्क्वेअर लिहू शकतो. मग इथं आहे का, ते आहे, इथं v स्क्वेअर इथं पण आहे आणि हे बाय लॅम्बडा स्क्वेअर इथं पण आहे. मग त्याच्या बदल्यात मी काय लिहू शकतो, त्याला लिहू शकतो n स्क्वेअर. म्हणून मग या केसमध्ये मला काय होईल, ह्या व्ही स्क्वेअर बाय लॅम्बडा स्क्वेअर त्याच्या बदल्यामध्ये मी काय लिहिणार आहे, हा इथं आहे बघा व्ही स्क्वेअर, हा इथं आहे बघा बाय लॅम्बडा स्क्वेअर. याच्या अगेन्स्टमध्ये हा व्ही स्क्वेअर हे होईल, हा लॅम्बडा स्क्वेअर, हा याला एन स्क्वेअर. मग त्याच्या बदल्यात मी एन स्क्वेअर लिहू शकतो. मग ही क्वांटिटी काय होईल, हे व्ही स्क्वेअर बाय लॅम्बडा स्क्वेअर जाईल आणि इथं हे इथलं जे काय आहे, हा इथं चुकून लॅम्बडा स्क्वेअर आलेला आहे, इथं बाय मिस्टेक हे इथं लॅम्बडा परत आला, इथं जी क्वांटिटी उरायला पाहिजे, म्हणजे आता ही लॅम्बडा स्क्वेअर इथून जर गेला तर इथं उरणाऱ्या क्वांटिटी जो पार्ट आहे फक्त ह्या ठिकाणी इथं व्ही स्क्वेअर बाय लॅम्बडा स्क्वेअर हे चुकून इथं तो आलेला पार्ट. सो रिमेनिंग व्हॅल्यू विल बी ओनली ऑफ दिस पार्ट दॅट इज टू बी देअर. सो दिस इज व्हॉट द सिम्पल इक्वेशन दॅट इज टू बी हे पार्ट आहे. इथून हे लॅम्बडा स्क्वेअर गेला तर उरलेला पार्ट म्हणजे इज इक्वल टू ट्वाइस पाय स्क्वेअर रो एन स्क्वेअर ए स्क्वेअर इज टू बी देअर. दिस इज व्हॉट द टोटल एनर्जी पर युनिट व्हॉल्यूम. So is equal to twice pi square rho n square a square. This is the total energy per unit volume propagating through any wave. But as far as with this relationship, what the relationship is to be there with the kinetic energy and the potential energy, this relationship clearly indicates that as far as the potential energy and the kinetic energy part is to be there, average kinetic energy per unit volume and average potential energy per unit volume are always equal. हे दोन्ही इक्वल असतात. अँड अगेन बोथ दी क्वांटिटीज आर हाफ ऑफ दी टोटल एनर्जी पर युनिट व्हॉल्यूम. आता बघा टोटल एनर्जी पर युनिट व्हॉल्यूम किती आहे, दॅट इज हिअर ई इज इक्वल टू आहे ट्वाइस पाय स्क्वेअर रो एन स्क्वेअर ए स्क्वेअर. ही झाली तुमची टोटल एनर्जी पर युनिट व्हॉल्यूम. पण आपण काय म्हणतो, ॲव्हरेज कायनेटिक एनर्जी आणि ॲव्हरेज पोटेन्शियल एनर्जी पर युनिट व्हॉल्यूम इक्वल असते. म्हणजेच याचा अर्थ काय, ॲव्हरेज कायनेटिक एनर्जी आणि ॲव्हरेज पोटेन्शियल एनर्जी हे दोन्ही सुद्धा हाफ असतात. कुणाच्या, टोटल एनर्जी पर युनिट व्हॉल्यूमच्या. जर समजा हे हाफ केलं तर उरते काय, मग इथं जर समजा बाय 2 केलं तर उरायले किती, पाय स्क्वेअर रो एन स्क्वेअर ए स्क्वेअर. म्हणजे हाफ ॲव्हरेज कायनेटिक एनर्जी ही झाली प्लस हाफ ॲव्हरेज पोटेन्शियल एनर्जी हीच झाली. आणि पाय स्क्वेअर रो एन स्क्वेअर ए स्क्वेअर हे डबल जर केलं तर हे 2 पाय स्क्वेअर रो एन स्क्वेअर ए स्क्वेअर होते. म्हणजेच याचा अर्थ ॲव्हरेज कायनेटिक एनर्जी पर युनिट व्हॉल्यूम इज इक्वल टू ॲव्हरेज पोटेन्शियल एनर्जी पर युनिट व्हॉल्यूम. आणि ॲव्हरेज कायनेटिक एनर्जी आणि ॲव्हरेज पोटेन्शियल एनर्जी ही हाफ असते कुणाच्या, टोटल एनर्जीच्या पर युनिट व्हॉल्यूमपेक्षा. आणि म्हणून आय कॅन राईट दिस इज टू बी लाईकवाईज दिस पार्ट. अगेन आता जर समजा ह्याच्यामध्ये प्रत्येक आता वेव्ह एकदाच थांबवत ना, म्हणजे एकदा सुरू झाली की वेव्ह कंटिन्युअस इज गोइंग टू बी देअर. प्रोपोगेशन ऑफ वेव्ह इज नॉट कंटिन्युअस इज टू बी देअर. सो इन दॅट केस इफ सपोज द एरिया ऑफ द क्रॉस सेक्शन ऑफ द बीम, ज्यामधून किती वेव्ह पास होते, सपोज टू बी हॅव्हिंग युनिटी 1. जर इफ सपोज दॅट क्रॉस सेक्शन एरिया इज हॅव्हिंग 1 and the wave velocity is supposed having to be v is to be there. So in that case again volume is what. आता इतक्या वेळेस आपण व्हॉल्यूम, डेन्सिटी, मास हे सगळं बघितलं, पण व्हॉल्यूम कसं काढतात, एरिया इंटू व्हेलॉसिटी, दॅट इज नथिंग बट टू बी युअर व्हॉल्यूम. आणि म्हणून तुम्हाला समजण्यासाठी पुन्हा एकदा इथं दाखवलं मी, व्हॉल्यूम इज नथिंग बट टू बी एरिया इंटू व्हेलॉसिटी. आता एरिया किती घेतलेला आहे आपण, दॅट इज टू बी 1. आताच म्हणला मी एरिया ऑफ द क्रॉस सेक्शन, एका युनिट एरियामधून जर समजा एक पर्टिक्युलरली वेव्ह वेलॉसिटी व्ही जात असेल तर त्याचं व्हॉल्यूम किती होईल, तर व्हॉल्यूम विल बिकम 1 इंटू स्मॉल व्ही. म्हणजे व्हॉल्यूम इथं किती होणार आहे, स्मॉल व्ही होणार आहे. आता हे स्मॉल व्ही एवढं व्हॉल्यूम जे आहे, सो ॲज फॉर ॲज दिस पार्ट इज गोइंग टू बी देअर इज गोइंग टू बी एनर्जी ट्रान्सफर पर युनिट एरिया पर सेकंड इफ आय वॉन्ट्स टू कॅल्क्युलेट. ई इज द एनर्जी ट्रान्सफर्ड पर युनिट व्हॉल्यूम. आता मला पाहिजे per unit volume per unit area, or that is to be the per second, that what amount of the energy is going to be transferred. तर त्या केसमध्ये I can write energy transferred per unit area per second, that is E into V is to be there. So E into V, small v, that is to be the velocity of the wave. So in that case I will write E is nothing but to be twice pi square rho n square a square, V is nothing but to be the velocity in that case. अशा प्रकाराने एनर्जी ट्रान्सफर पर युनिट एरिया पर सेकंद इज नथिंग बट टू बी दिस मच ऑफ अमाउंट. दिस एनर्जी इज ऑल्सो कॉल्ड टू बी ॲज ए एनर्जी करंट पर युनिट एरिया. आणि याच केसमध्ये आणखीन एक गोष्ट अशी क्लिअर होते की कायनेटिक एनर्जी इन जनरलमध्ये आणि पोटेन्शियल एनर्जी ऑफ एव्हरी पार्टिकल इज चेंज विथ द टाईम. इन जनरलमध्ये कायनेटिक एनर्जी अँड द पोटेन्शियल एनर्जी चेंजेस विथ द टाईम. but average kinetic energy and average potential energy per unit volume remains constant, and that is what the very important factor to understand as far as the propagation of the wave is going to be there. As the propagation of the wave is going to be there, the energy transferred per unit area per second is nothing but to be twice pi square rho n square a square v is to be there. This much amount of energy is going to be transferred per unit area per second, and this is also called the energy current per unit area, and that is also going to be the constant. That is, kinetic energy and the potential energy in general changes with the time, but average kinetic energy and the average potential energy per unit volume remains constant. Average kinetic energy and the average potential energy always half of the total energy per unit volume, but average kinetic energy and the average potential energies are constant and similar in that case. This is all about the whatever be the energy transferred in that case. And again, the part where the very important factor that wherever the wave is going to be propagating, in that case, to understand how much amount of energy is going to be transferred. So this is a very important factor as far as the energy propagation or the energy transfer is to be there, that whenever the wave is going to be propagated, energy is going to be transferred, but the medium is not going to be transferred, or the matter is not going to be transferred. Only energy is going to be transferred in a propagation of the wave is to be there. So this is all about from the my side. Take care, be at home and be safe. Thank you.